Hi everyone, welcome to our fourth tutorial. In this video, we'll discuss logic definition in Web Assistance. Web Assistance logic is responsible for processing the user answers to generate an advice or to solve a problem. In Advicenode, there are two types of logic, the decision-making logic and the processing logic. In this video, we'll focus on the processing logic. Processing logic is composed of different processes. Each process can do a certain function in the Web Assistant. Each process should be started with a start component and ended with an end component. In between them, other components can be added to form its logic. These components should be connected together to form a process diagram. This diagram should flow from left to right. Each component in the process can do a predefined operation. This operation may require some input parameters and may generate some output parameters. For example, this component can do simple mathematical operations, like adding two numbers. In order to operate, it must get those two input numbers. It will also generate an output parameter that represents the result of the addition. Passing and retrieving data to and from any component is done through what we call variables. Variables are data items that may take on more than one value during the process flow. Each variable must have a unique name, a type, and a value. The variable value can change, but its name and type can never change. Each variable has a limited scope in which it can be accessible. In Advicenode, the variable scope is limited to its containing process and to the component defined after its creation. For example, in the math component, it receives two numbers and produces a new one. The output number can be saved in a new variable or be assigned to an existing variable. If a new variable is created, then only those components defined later can access its value. Advicenode supports mainly 6 variable types: text, number, flag, number vector, text vector, number matrix, and text matrix. There are other variable types for processing the data resources, but we won't discuss them in this video. On the other side, processes have only two types: callable processes and non-callable ones. Callable processes are those which can be called by other processes. Callable processes are built for doing a function designed by the assistant owner. Callable processes can take input parameters and generate some output parameters. On the other side, non-callable processes cannot be called by any other process, and they cannot have any input or output parameters. These processes are called only by the system to start processing. Accordingly, each web assistant must have at least one non-callable process to be the logic starting point. Now, let's create a callable process that can get some information about the bet breed. To open the Process Designer, double-click on the Processes icon. We have a non-callable process created. We'll create a new callable one. I'll call it Get the Breed Info. Let's check the callable checkbox. Now, to open the Process Studio, double-click on the New Process icon. Here we go. Before building the process, we can define some input and output parameters. In our case, we'll define one input parameter for the breed name and some output parameters for the breed information. Now, I'll add the Start component. You can click on any component to access its properties. You can set here any layout, operational, input, or output parameters. You can also check the variables within scope and find the errors if exist. For this component, I'll change its name to Start and click Save. First, I need to know whether the user is seeking information about a cat or a dog. So, I'll need to access one of his or her answers and compare it with a specific value. Therefore, I'll add a text comparator to my process. It will check whether the answer collected has the value dog or not. As you can see here, this component has some input and output parameters. For input parameters, it needs two text variables. I'll set its value from user answers. You can access the answer of any question by selecting its group, page, and name values. Finally, let's set the output variable. I'll set its name to a dog pet. Because no variable exists with this name in the current scope, a new variable will be created. The output here is of type flag, which means it can have the value true or false. So if the user answer is dog, then this flag will have the value true. Otherwise, it will have the value false. Eventually, we'll use this flag to know which lookup table to fetch data from. Currently, we've two lookups, one for cats and one for dogs. I'll add a condition component. This component will rely on the flag variable created by the comparator. Condition component is the only one that can originate two arrows. The first arrow represents the logic to be executed if the flag has the value true. The second one represents the logic to be executed if the flag has the value false. Hence, I'll start with the dog logic. I'll fetch its breed information from its lookup table through a search lookup component. This component can fetch a single row from any lookup defined in our assistant. I'll add an input parameter that represents the column I like to search with. The lookup table we uploaded for dogs holds only 4 columns. Accordingly, we can retrieve the row into 4 variables. We'll set the average weight, general health, and lifespan to the process output parameters. Let's repeat the same for cats. Afterwards, I'll end the branches. The upper branch will be executed only if the flag has the value true. Otherwise, this branch will be executed. Now, I'll end the process. This process is now ready to be called by other processes. It takes the pet type as an input and returns its equivalent information. Let's save it. I'll open the non-callable process. Let's remove this connection. Add a process call. Choose its name, and set its output parameter. I need to show some of this information to the user, so I'll send it to the reporting layer through one of the interpretation components. There are 4 types of interpretations. Interpret text can send any text to reporting. Interpret vector can send any number or text series to reporting. These series can then be transformed to tables or charts. Interpret images can send some image details to be displayed within the report. Finally, interpret cards can display any number of clickable cards to the user. In our case, I'll use the interpret text component. If you'd like to know how to use any component, just right-click on it and choose Help. To learn more about the logic processes or the decision making, please visit docs.advicenode.com. If you have any questions or need any help, please feel free to ask in discuss.advicenode.com. Thanks for watching.